today.
Nice, that's pretty nasty.
Yes, it is. Ian was sick yesterday,
Yeah.
so I think he's sick, and we know Adnan is sick. So it'll be just the two of us today.
Nice. Look at you.
Look
Look
at
at
you.
Look at Stephen.
Tell Stephen not to don't open the door because
Yeah, we should.
tomorrow I will be sick and he will be alone.
I like to have the window open in the class. I'm
Right.
sure he doesn't. So our balance is we have it open for exactly half the time
Okay.
and closed for the other half.
Okay. So sure, why would you want the window open and the window open?
Yeah.
I just get me in there.
It's a bit warm.
Right. I'm just intrigued to see the little thing. Because I only ever see you in the other classroom.
I'll use this. Now, I'll have to show you a toy I got from one of the students now. You'll like this. One of the January students sent this to me. You can probably guess from the name of what it might be.
It's Miss Knock.
Miss
Knock, is it?
what?
Okay, sorry, no.
What'd you say?
Do you remember you were probably too young, one of the really, really, really old computer games was called Miss Knock? And it was one of those ones where it was like black and green screen, and it was Miss Knock was a cleaning lady and she had to pick up all of the rubbish,
No.
scoot around, and one of the things she had to pick up was wine glasses, but she used to start drinking the wine. If she drank too much of the wine, she started dropping the laundry and all this.
Hey, goodness, I've never
Did you ever
heard
heard
that
that?
name. Miss Mop?
Miss Mop.
Miss Mop.
Yeah. Now we're talking like.
Arcade?
No, well, I would have played it in like kind of 1985 type thing in my cousin's house because they had a computer.
Yes, yes, yes.
Ooh, I do like that.
I thought you might.
Yeah.
So this is the calculator I recommend the students to buy. I got this last
It has all the
week.
functions.
Does the same things, yeah. So I was showing students yesterday how to like use different features on it and all this type of stuff. But this calculator has built-in integration. You can like.
But they're not allowed to use. You're not allowed to use those for.
No, you are.
Are you?
It's just for this you wouldn't get any. I tell the students you can use this to check your answer, but if you just typed it in and put down the answer, you wouldn't get any
Oh,
marks.
you should show methods. Yeah.
Yeah,
Okay.
but I said you're welcome to check your answer,
Absolutely.
see that you got the right answer.
Yeah, I totally don't remember. That doesn't make any sense.
No.
But that's fantastic. And is it a free download?
I got it for free.
Yeah. Not the same thing.
We won't ask any more
No,
questions.
no. That's fantastic.
Yeah, it's nice because Joan was noticing this as well when she was looking at YouTube videos of teachers putting up maths videos, but they have a calculator that they put up, which I thought would be dead handy
Oh, that's
to have that, because that will be recorded in the video as
Yeah,
well,
yeah.
rather than me having to say. Because what I used to be doing is I used to turn the webcam on and hold it up to the webcam,
Oh, that's
but
brilliant.
this is much neater.
Yeah, and the quality of it is really good as well. It looks very kind of solid,
Yes.
doesn't it? You
It
know?
doesn't look like a JPEG.
No, it really doesn't.
Yeah.
It looks like a picture of the farmer.
Yep.
Calculator, it's great. Anyway, obviously I am looking for reasons to avoid doing real work. So I leave you guys.
We'll start the real work now, so.
Start the real work here, yeah, exactly. Enjoy.
Alright, see you later,
Good
so.
night, bye.
Okay. Yes. From the last one, great. Well, we have plenty of time. Let's have a look. So, what is the question?
1 over 9. And the U is sine.
Good one, yeah. Use sin x. So first, I'll change this into sin x over cos x. Are you happy with that? Yeah. And are you happy if I change this into cos x over sin x?
Wow.
I can.
Yeah.
Yep. U du dx equals cos x. Du over cos x equals dx. I can put that in there.
Yeah,
And then it's finished, yeah. Yeah.
and there is another one.
Okay. Mhm.
Those are the two that are not straightforward.
You have two that are not straightforward.
Yeah.
Yeah. Did you find it? You're looking?
Integration
Mm-hmm.
2 to power sin x.
Like this. Let me guess.
Yeah.
So that means du dx equals cos x. So du over cos x equals dx. So this is 2 sin x cos x du over cos x. So this is 2u du. And we did this one.
Yeah, it will be 2 sin x plus 1.
This one here will become 2u log 2. See, this is one, yes, we did this one
Yeah.
implicit, which will be 2 sin x log 2.
But I thought that if you for the not for the integration, I thought it's for the differentiation.
Oh yeah, actually, hang on, I think I did something wrong, did I? Yeah, over log 2, thank you. Because what happened was last time we said if y equals ax, then dy dx equals ax log a. So if you want to integrate ax dx, yes, that's the same as log a, no it's not, that's 1 over log a, integrate ax log a dx. This here is ax. Now watch, listen. The derivative of ax is ax log a. We proved that. So that means the integration of this is ax. So what I did is I put in a log a and a 1 over log a.
Yeah, and it will be 1 over log
Yeah,
a.
yeah, that's it. Ax over log a. Is that the answer I have it back?
I didn't.
Okay. Do you want to write this down?
Yeah. Can I write that?
You want to go to the next page? Oh dear.
Yes, you.
Oh, I'm sick and tired. I'm hungry. Well, no, I'm not hungry actually. I'm just sick and tired. You need to write this down, is it?
Yeah.
Yeah.
How did you know the another one, the U is sin?
I said in the question, didn't I?
Yeah, but from where? How did you?
My brain. I've been doing these for so long.
But if I want to do it, how?
Your best guess is to use what's on the inside. Sine x is on the inside of 2. Do you know what I mean? Try to zoom in to what's on the inside. Okay, so will we start the next lesson then? Yeah. Workbook. Maths part 2. No. Yes. Engineering. Did you get a message from Iyad?
Integration of simple rational function.
No problem. Let's have a look. So we've done by substitution. Where was that sine x one? Oh, here it is here. Yeah. Okie dokie. Now don't forget, this question actually had a log 2 in the front. Did you see that?
Yeah, but one...
It means you multiply your answer. Yeah.
We do sine x.
Okay.
I did this before.
Did you? Yeah. Before we start this one, some examples. Not some examples, some formula. So, I have y equals tan inverse x. So that means tan y equals x. So that means 1 over cos squared y dy dx equals 1. Derivative. So that means dy dx equals cos squared y. X 1 y, because it's over 1, yeah? So this is square root 1 plus x squared. So that means dy dx equals cos y squared, which is 1 over root 1 plus x squared. So that means dy dx equals 1 over 1 plus x squared. That means the derivative of tan inverse x equals 1 over 1 plus x squared. So that means tan inverse x is the integration of 1 over 1 plus x squared, with the plus c, of course. So in other words, the result is integrate 1 over 1 plus x squared. That's equal to tan inverse x plus c. Okay, now they sometimes ask you to prove this in the exam. They've asked it twice in the last maybe 9 years. So there's some proofs in the second semester. Not many proofs, some proofs. So I don't know if you want to write this down or... Yeah, I think it's good to write down the proof. So it starts here and then continues here, and then this is the result. Yeah? Okay, so now let's have a look at some questions. Minus 8x plus 6 minus 4 x squared plus 6x plus 5 dx. So I've done 4 different questions because there's 4 types of problems. The first one is a linear over a quadratic. Usually, the way to solve this is by making u equal to the denominator, like this. Yeah. That means du dx is minus 8x plus 6. So this becomes minus 8x plus 6 over u. Dx equals du over minus 8x plus 6. du over minus 8x plus 6. Cancel. This becomes log u. Yeah. So that's log minus 4x squared plus 6x plus 5 plus c. And that's it. Yeah, that's a simple first example. Yes.
So I have to do all these steps. When you look at this, you find down is the derivative.
I understand. No, I understand. For this one, no, it's okay. Yeah, next example. Integrate 6x minus 7 over 2x minus 9. A linear over a linear. Now you might think this is easier because it's linear, but it's actually harder. So you have u equals 2x minus 9. Du dx equals 2. Du over 2 equals dx. So this becomes integrate 6x minus 7 over u du over 2, which is a half 6x minus 7 over u du. And you can see, oh, still an x here, but of course we can use this. We can say u plus 9 over 2 equals x. Yeah? So I can put that in here for x. So I get a half integrate 6 u plus 9 over 2 minus 7 over u du. Like this. Yeah? Now, here 2 goes into 6 3 times. So I have here 1 over 2, 3u plus 27 minus 7 over u du. This is a half 3u plus 20 over u du. A half 3u over u plus 20 over u du. Which will be a half integrate 3 plus 20 times 1 over u du. I just wrote it like this. The u's cancel here. and this is 20 times 1 over u. So then this will be a half 3u plus 20 log u plus c. So that's 3 over 2u plus 20 log 2x minus 9 plus c, which you can actually write as, when these multiply, it becomes 3x, and I don't care about the 9 times 3 over 2, because I can put that with the c. So then this is the answer. This is harder than the last one, but they ask this in the exam as well, and maybe they tell you this, but maybe not. Like in the last one, maybe they tell you, maybe not. Okay, so you probably should write this one down. Yeah.
Hey Stephen, do you have a spare marker?
Do you know, Mark, I have no markers because I use my projector, so sorry about that.
You're no good.
I'm useless.
Did you hear from the bank?
No. Now, I realised they told me lunchtime yesterday,
Right.
but of course,
Well, maybe it was a 10-course lunch.
well, I was thinking yesterday when I was leaving, it's like, you're not going to tell me on Monday because it's only Saturday and I know things don't move that quick, so why are you lying to me?
Yeah.
Like, you'll work really hard for me and all this. Isabel might have a marker.
Better to do that. Assalamu alaikum. Sorry for interrupting your class.
Okay, do you have this? Not yet? Yep, good stuff. Right, next one. Now we're getting interesting. 16 over 4x squared plus 1 dx. Okay, now here's the trick. This is a constant over a quadratic. We let u equal to the square root of 4x squared over 1. Yeah? Continue?
Yeah.
Okay. U equals 2x over 1. So you let u equal 2x. du dx equals 2. So dx equals du over 2. Okay, so this will be 16 over 4x squared plus 1 du over 2. Now, what about this 4x squared plus 1? Well,
Square.
Yeah, it's going to be u squared. Yeah, you can say x equals u over 2. Or you can just square both here, whichever you prefer. So this would be 16 over 4 u over 2 squared plus 1 du over 2. And you can see that this is u squared plus 1 du over 2.
Yeah.
That goes in to make 8.
8.
Yeah. So you have now 8 integrate du over 1 plus u squared. You know then that this becomes tan, because that's what I gave you earlier today. So the answer is 8 tan inverse u, which is 2x, plus c is the answer. Okay, so you probably want to write that one down. This is like on the side. Yep. Okay. Next example. Now we're getting interesting. Okay, Ms. Sharif, what do you think we should do first?
U equal 4x squared. No? Minus 8.
Nope.
Plus 8.
Nope.
Square root 4x squared.
Nope. See, this one is a bit hard. So first what I do is, at least I can divide everything by 4, firstly. Okay? Then I complete the square. X. You remember completing the square? Now, here's the trick. Now I say let u equals square root x minus 1 squared over 1. So then u equals x minus 1. So that means du over dx equals 1. So we get du equals dx. So we have du equals dx, u equals x minus 1, and x would equal u plus 1. So if I go back here, this would be 4 over u squared plus 1. That's the u there. Yeah. Du, which would be yeah.
4x squared. How do you get u squared?
Here, because x minus 1 is u. So x minus 1 is u.
Okay. You didn't substitute in the first one. Okay.
No, actually, it's more convenient to substitute here. Now, interesting. If you take the x here and here and replace it with this, it will make this, it just takes longer to do. So if you put this in here, or you use this one in here, you still get this answer. Continue. So this is 4, oh no, I was going to write here. Well, I'll write underneath. So this is 4 du over u squared plus 1, which is 4 tan inverse u, which is 4 tan inverse x minus 1 plus c. That's the answer.
It's very different to what I did.
You're here to learn something new.
Yeah. But when I looked first, I thought it's the same. Looks the same.
It looks the same, yeah. Okay. So, well, for the first lesson, I've done each of the 4 examples. The next.
Go.
Yeah, sorry. To this?
Yeah. So it's 4 methods.
4 problems, yeah. So I did 1A, 2A, 3A, and 4A. So maybe what you could do now is 1B, 2B, 3B, and 4B to practice, you know. What do you think? And then after you do those 4 questions, we can go to the next lesson. And then we can relax. Do we have physics later? Oh yeah, we do. Will it just be the two of us? Probably just be the two of us.
My maid will be.
Huh?
His maid will be.
I thought he was at the dentist. No?
I'm not sure.
Not sure?
It's more than
You don't think it's today?
No.
Yeah, okay. Right, well let me just stop this and how about you do those 4 questions? When it's finished we'll do the next lesson. You said you've seen 3 of them before? 2 of them? How many?
I think
2.
two.
So 2 old, 2 new. The first one you saw?
Yeah.
Second one?
Yeah.
But third and fourth, I see.